Hello everyone, welcome to this video. We'll be solving the problem of the day today. The problem is replace O's with X's. So here is the problem statement. It says given a matrix mat of size n cross m, where every element is either 0 or x, replace all the zeros with x that are surrounded by x. And what do they mean by surrounded? Well, we have an O or a set of O is considered to be surrounded by X if there are X at all location, just below, just above, just left, and just right of it. Okay, so let's understand the problem in even more clear manner using one example. So here is the first sample case. So we are given n and m, the size of the matrix, and the matrix with the values x and o's. Fine. So now what do we have to do? We have to find out o's, or we can say set of o's that are completely surrounded by x, right? And in what direction do we have to check? We have to check up, down, right, and left. These are the four directions that we have to check in. Okay, so once we go here, we need to make a check with this O, right? What we are doing, we are finding if our O is actually surrounded by X, right? So when we consider this O, on the three side, it is covered with X, right? It is surrounded by X. If we talk about this O, this is surrounded from this side, and on the other two sides there are O's, right? So we are considering this to be one complete set. Okay, and this set, like for this O, it is surrounded by these three X. For this O, this is surrounded by these three sides. Okay, so we can say in a manner that this complete set is completely surrounded by X. Okay, that means all the zero inside here are going to be converted to X. So once we do that, the matrix would be like this. Fine. Now once we go here, once we check here, this O is actually surrounded by X only on the two sides. Okay, and in this side, it is actually open to the edge, which is not considered. So we cannot consider this O to be following our rule. And for this O, the same thing, it is not covered from these two sides. It is not surrounded from these two sides. Thus, we cannot convert these O's to X's. That means these are going to remain as O's. Okay, so this is going to be our eventual matrix that we have to return as the answer. All right, now let's take one more example and try to understand it well. All right, now for this one, we can say that once we enter from here, we can say we have encountered one O here. Now we'll check from how many sides this O is actually surrounded by X. It is from this and this, but open from this side. That means the whole set associated with this O is going to be remain unchanged, okay, because one side is exposed, that is not covered, that is not surrounded by X, right? So this O, like this complete set of O's, is going to remain unchanged. And talking about this O, it is also covered from only these two sides. These sides are exposed of this set. This set is also going to remain same, it is not going to change. So all the X's are going to be not converted anytime, and all these zeros too are going to remain as it is. These are not going to be changed. So the matrix eventually will be returned as this without any change. This is the answer matrix for this problem. All right, so now that we know what do we have to do, how can we do it? Okay, what could be the approach? So the very first intuition that anyone might have is going to be based upon directional traversal, right? Firstly, whenever we are standing somewhere, we need to know that how we can check its neighbors, correct? We need to first know how we can check its neighbors, because only after then we can come up with some logic. So one should be very clear about how four direction traversing in matrix work. Assume if you are standing here and the coordinates are 0, 0. Okay, just taking some random value, and you have to move to this cell. What would you do? Well, actually what you're doing is you are going upside, right? That means you are reducing one row and you are remaining at the same column. Thus, it means that what you have to do is you need to minus 1 from your x, and you need to do not add or subtract anything from your yth, where I'm considering x to be the rows and y to be the columns. Fine, this is going to be the coordinate, and if we move to this one, what are we actually doing? We are switching up the column. We are increasing the column. That means this is going to be 0, comma 1. 0, x remains unchanged. 1, that means y plus 1 now. For this block, what do we have to do? For this block, if we are at 0, comma 0, here what we are doing is we are not moving the column, but we are moving the row. And we are adding one row. We are going on this side. So it is going to be 1, comma 0. For this cell, what do we have? We are reducing one column and we are remaining in the same row. So it will be like 0, comma minus 1. Now we know how can you figure out the 4 directions of one cell, right? This is what we have to do with our zeros. We need to check in the 4 directions that if, or you can say the O's, we have to check it with our O's at in the 4 directions if there are X's or not. So the basic intuition that anyone might have is, firstly, we have to traverse the borders and convert all the zeros and associated groups to some other character, right? See, very basic thing. If you are like starting to solve this question, which zeros we cannot change, we need to focus on that. All the zeros which are somewhere exposed to the boundaries, right? Only then is going to be the case that it will be covered with x's from all the sides. Okay, so all the O's which are at the edge or the set they are composing is somewhere exposed to the edge need to be sorted, like need not to be changed. So firstly, we have to take care of those. Assuming in this example, what I'll do is to mark all the O's which are somewhere or the other touching the edges, what I'll do, I'll traverse the edges, and whenever I find one O, what will I do? I'll call one DFS function there. Okay, and what is going to be the duty of this DFS function? To convert all the O's associated with it in the 4 directions to some other character. Let's say I convert it to -1. Okay, so all the O's connected to this O will be converted to -1. All right, that means this whole set will temporarily be -1s. Correct. Now, what is the next step? And for these two as well, because these are at the corner, these are touching the edge, these will be converted to -1 as well. Now assume like you might have had a bigger values. You might have had a bigger matrix. What will we do then? And here we have one situation. Just give me a second. And assume we have this extension here. Now, what is the change? That means we now have one set of zeros available which can be converted to x's. Now, what do we do? Once we are done with it, we have traversed the borders, and every O that is exposed to the edge, we have converted the whole group of O's associated with it with -1. Right, that step is done. Now what I'll do, my matrix will now be having x's, -1, and O's. Right now, now my duty is to convert all the remaining O's to x, because those are the O's which are actually covered with x's. Fine. Then I will simply just traverse my matrix completely using nested loops, and what I'll do, I will convert all the remaining O's to x. Once that is done, now again, because I have to return the answer, what I'll do, I'll again traverse that matrix, and this time all the places where I'm having -1, I'm again going to set it back to O's. Okay, this is a 3-step, and in these 3 steps, this whole question will be solved. Okay, again, let's see the approach of it. What am I going to do? Firstly, I will traverse for I0 and in-1. I0, this value, and in-1, this value. And what I'll do, I'll go for J0 till M minus 1. That means I'll go from J0 to N minus M minus 1 for J. That means this. While using this traversal, this row and this complete row will be traveled. All right. And with the traversal, what do I have to do? I have to keep on checking that whenever I encounter any O here, I'll call a DFS function. In our example, I was encountering one O here, right? And once we have called DFS function from here, the DFS function will be converting all the O's associated with this O with -1. This is what we have thought of, right? This is how it will go. Now, once this is done, the next step is going to be converting, like taking care of these edge columns. So what I'll do, I'll go for J0 and JM minus 1. That means this side and this side. And my I is going to be from 0 to N minus 1. That will cover my whole edge columns. Fine. Again, the same thing. Whenever I encounter an O, what will I do? I'll call one DFS function. Fine. Okay. Now, once that is done, once my DFS work is done, that means all the O's which are exposed are going to be converted to -1, and all the O's which are not exposed, which are actually surrounded, are going to be remaining as it is. Fine. Now, what is our duty? To convert all the remaining O's to X, first thing, that is what I'm doing here. Then to convert all the -1 which are there to O's. Fine. This thing will be done and the question will be solved. So again, let's see what is going to be the design of a DFS function. Simply, the DFS function will be having 3 parameters, are ij, to identify the cell and the matrix, nothing else. The very first thing that we have to do is we have to change the element to -1. So whenever we are making a call, the first thing is we are converting that O to -1. And then we have to check in all 4 directions, the 4 directions that I mentioned to you. And we have to see, you are standing here, you need to take care of all the 4 directions. Okay, you need to see that if that block is also having O, fine. If that block is also having O and is a safe block to travel. And what do I mean by safe block? That means the block is inside the boundary of your matrix. Assume this is the boundary of your matrix and we are talking about this block. Okay, we are calculating this cell which is not even inside the matrix. Then we cannot call DFS upon it because that is outside the matrix, right? So let's talk about this column which is inside the matrix. It is going to be a safe place to travel. And we have to check that if this is also an O, then what do we have to do? We have to call DFS function upon it. Okay. And then this DFS will do its work. It will convert to -1. Again, it will backtrack here. It will go to the other direction. It will see if that is also an O, that will also convert it to -1, and so on and so forth. The whole group of O's will be converted to -1. All right, let's see the code for it. Okay, coming here. Just as we have seen in the approach, what am I doing here? I'm traveling for both the rows, for the edge rows, then I'm traveling for edge columns, right? Once that traversal is done, I'm traversing the whole thing for converting my O's to X's, and then for all the -1 to my O's. Fine. The logic is pretty clear. Let's dry run it. Okay. So for the very first time, I'm going to be traversing the first edge row of my matrix here. So once I'd be traversing it, I'll check that if my mat I, 0 is O. For this one, no. For this one, yeah, I got it as O. What am I doing? I am calling the DFS function for this block. Once I call the DFS function, I come here. Okay. Once I come here, now what will I do? I'll firstly set mat ij to -1. That means this value is now going to be set as -1. Fine. Now, once that is done, what am I doing? I'm saying for D in directions. What are my directions? These are my 4 directions that we have talked about. I'm going to be creating new ij, which are new possible indexes, new possible cells, which we can travel from this block From this block, firstly, I'll do minus 1 comma 0. Minus 1 comma 0 means this. Okay, again, we are talking about this block, but we cannot call the DFS function because it is invalid. It is outside the boundary of matrix. What will I do? I'll first check that if my new I and new j are actually valid, this function is taking care of it. And here it is. It is seeing that if my I is lying between 0 and length of the matrix, and if my j is lying between 0 and length of the column. Fine. So if that is a valid block, only then I'm going to check that does it have O. Because this is invalid, we are not going to even make a check. For the next thing, we have 0 comma 1. That means this one, right? That means this one. We'll check that if it is valid, yes, it is valid. But does it have O? It does not have O, right? Now moving forward, we'll check this block. Once we are checking this block, it is also valid and it does have O. We will call the DFS function, the recursive DFS function here. Then what will happen? Then once we do that, this will be converted to -1. This will be converted to -1. Again, the same checks. This is valid, but not O. This is valid, but not O. This is valid and O. This will also be converted to -1. Again, we are going to be checking the same things. This previously, this one is valid, but not O. This one is valid and it is O. It will be converted to -1. This one is also valid and will be converted to -1. Further on, this block is valid, but not -1. Fine. But not 0, but not O. Thus, it will not be converted to -1. Fine. So this is how this whole block of zeros will be converted to -1, right? And this is how it will be looking. Okay, all the O's of that group converted to -1. Now we are going to, again, the work of DFS is done. We are again going to come here and we'll be completing the check of the row. This is not O, this is not O. Now we will simultaneously also be checking for our this edge row, correct? The last row. We are done with this first row. We have to also check this row, right? For this row, this X won't be called because we do not have O here. This won't be called. This will be called. Once this is called, this will be converted to -1 and this will also be converted to -1. Fine. So once this is converted to -1, it will be looking something like this. So after the successful execution of our DFS, this will be our matrix. So in case of this example, we are not having any value being left as O. Why? Because there are no surrounded O's. Okay, this is a special case for this particular example that I've taken. You might be having some other O here if we have an extension and it might be covered with X. Then in that case, we are not going to be converting this O to -1. All right. Once this is done, see, I'm not taking this case. Let me raise it. For me, this is the question. Now what I'm going to do now? Now, once I'm done with DFS, now I'm going to be doing this. That means converting all the O's to X. We will be checking for the whole matrix, but for this particular matrix, we won't be getting any O and we won't be converting it to X, but we only have -1. The last thing that we have to do is we have to convert all the -1 to O's. That means wheresoever I am having all the -1, which in terms mean all the exposed O's will be again be converted to O's. And this will be our answer matrix and we'll be returning at. Okay, so once we have returned that, this is going to be our final answer. Okay, now discussing upon the complexity of it. See, no matter how many times we are calling, the worst case could be like all the elements are 0, or one edge case could be like all the elements are X's, right? All the elements could be O's or all the elements could be X's. In both the cases or in any of the middle cases, what will be happening is we will be traversing M cross N, and that is going to be sum of the constant times, right? So for that, we can say we are actually doing it for O m cross n. Let's quickly run this code and see if it is working properly. Okay, so here's the same code. Now let me compile and run it. All right, so it is compiling properly. Let's try to submit that. Okay, so I hope this video helped you and now you understand how this question is solved. Again, if you have any confusion, try to rewatch the video and all the doubts will be solved. Thank you.